Okay, so let's continue with the tutorial. So the tutorial is going to be number 6. Okay, and the question says the following: solve the following system of equations. System of equations using Gauss-Jordan reduction. Okay, so here is the system of equations. We have 2x plus y minus z equals 2, and 4x minus y equals to 3. Okay, so how do we do that? First of all, let's write the system as an augmented matrix. Okay, so step 1, we need to, if you recall from the lecture, how do we perform Gauss-Jordan reduction? Step number 1, we reduce the system to its echelon form. Okay, so let's do that. Maybe let me change color. Step 1, reduce the system to its echelon form. Okay, so we are going to use the augmented matrix of the system. So we have 2, 1, minus 1, 1, and here we have 4 minus 1, 0, 3. Okay, so let's perform Gauss's method. Okay, so we are going to use the 2 here to eliminate that 4. So this leads to minus 2 rho 1 plus rho 2. Okay, it gives us 2 here, 1 minus 1, we have our 1 there, and then we have a 0. Okay, minus 3 and 2 here, and minus 2 plus 3 is 1. Okay, so basically we have finished with the Gauss's method. So this is the echelon form of the matrix, but we are not done yet. We need to turn each leading entry into 1. So step 2, make each leading entry into 1. Each leading entry into 1, if you recall. Okay, so we are here. So we are here. Step number 2. Okay, we have done step number 1. Now we are dealing with the step number 2. Make each leading entry into 1. Okay, so our echelon form of the matrix is 2, 1, minus 1, and 1, and here we have 0, minus 3, 2, 1. So How do we turn the entries, the leading entries into one? We are going to divide, when it comes to the first row, we are going to divide it by 2. So half row 1 will give us 1 a half minus a half and a half. Okay. Then the leading entry for the row 2, for the second row is minus 3. So we need to divide it by minus 3. So minus 1/3, okay, of row 2. Multiply row 2 by minus 1/3 will lead us to 0. 1 minus 2 over 3 and minus 1/3. So step number 2 is finished. Each of the leading entry is turned into 1. Okay, now step 3. Step 3. What does step 3 say? Step 3 says the following. It says use each leading entry to eliminate all of the other entries in each column by combining upward. Okay, so let me write it down first. Use each leading entry to eliminate all the other entries in each column by combining upward. Okay, so what do you mean here? Let me write the last form of the matrix. So we have 1 a half minus a half, and here we have a half, 0, 1 minus 2 over 3 minus a third. Okay, I hope I will have enough space. Okay, let's hope so. Okay, so basically what it says is, you see here, if we take the second row, the leading entry is 1. And if we take that column where the leading entry is 1, this column here, okay, let me start with the first leading entry. Okay, so let's start with row 1. Row 1, its leading entry is 1. Okay, and do we have any other entry upward above 1? No. Okay, so we have to start with row 2. If we take row 2, its leading entry is 1, and above 1 there is a half, so we need to eliminate that half. Okay, by doing what? By taking minus half row 2 plus row 1 to be able to eliminate that half there in that column where the leading entry in row 2 is 1. Is that okay? So basically that is what it means. So I have minus a half row 2 plus row 1 will give, so there is nothing being done to row 2, so I have to recopy it, minus 2/3, and here I have minus a third. Now I am taking minus a half row 1 plus row 2, I still have, sorry, minus half row 2 plus row 1, I still have 1 there. So here minus a half plus a half is 0, of course, that's why we are doing it, so that should be 0. And minus a half, so that's going to be, here we have 2 So that's going to be a third minus 1/2. So that's going to be 6. 2 minus 3. So that's going to be minus 1/6. Okay, so we have minus 1/6 there. And when it comes to here, I have here multiplied by minus 1/2. So it's 1/6 plus 1/2, which is 6. 1 plus 3, which is 4/6, which is 2/3. Okay, so I have 2/3 there. Okay, so we are done with the Gauss-Jordan. Okay, so that's the end. That's our final answer. And as you can see, this is x, y, z, and here is the constant. These are the constants. Okay, the constants there. So we can read the solution easily here. We can see that y equals to minus 1/3 plus 2/3 of z. Very easy, right? And here we can see that x equals to 2/3 plus, so we have to bring this to the other side, plus 1/6 of z. You see? So that's the advantage of Gauss-Jordan. Easy to read. So now here is the solution. Here is the solution set. Okay, so here we can write, when it comes to row 1 can be written as x equals to 2/3 plus 1/6 z. Okay, and row 2, in row 2 we have y equals to minus 1/3, okay, plus 2/3 z. Okay, so we are parameterizing the leading entries with the free, we are parameterizing the leading variables with the free variables, and in this system the only free variable we have is z. Okay, so now how do you write down the solution set? X, y, z, okay, is going to be equal to, our x is 2/3 plus 1/6 z, y is minus 1/3, okay, plus 2/3 z, and z is just z. Okay, therefore we can rewrite this big matrix, this big vector, as the sum of 2. So we have 2/3 minus 1/3, 0, plus 1/6, 2/3, and 1 times z. So finally the solution set is x, y, z equals to 2/3 minus 1/3, 0, plus 1/6, 2/3, 1 z, such that z is free. That means z is r, can take any value in r. Okay, so that is our final answer. Okay, so I'm going to stop it here. So that's how you perform Gauss-Jordan reduction or Gauss-Jordan method. So you go through these 3 steps. Is that okay? Thank you, and see you in the next video where we will continue with the lecture. Thanks.